So work package 2 in the OpMetBat project is about best practice. So what do I mean by that? Well, in operando spectroscopy, what we do, as the name suggests, is apply spectroscopic techniques to measure the physical, chemical, structural properties of materials and devices in their operational state. And that may be techniques such as X-ray spectroscopy, X-ray diffraction, or vibrational spectroscopy. And it can tell you a lot in the case of batteries about the various processes that are happening in the materials during charging and discharging. And ultimately that can tell you or help you develop better battery materials. The problem with operando spectroscopy is it's very, very difficult to do in that even many of the techniques by themselves are challenging. So when you then combine them with electrochemical techniques, it's very difficult to get reproducible data or repeatable data. And so that's what work package 2 in the project is about. It's trying to develop best practice so that repeatability and reproducibility of operando spectroscopy measurements is improved. And ultimately, what we want to improve confidence in the data generated by these techniques. So the work package 2 is broken down into 3 parts. The first part is basically focusing on cell design. So one of the big problems with people undertaking operando spectroscopy is that everybody does it differently. Everybody uses different electrochemical cells and different spectroscopic techniques. So what we're going to try and do is improve the cell design, optimize the cell design using physical modeling, and ultimately we want to validate the cell design to make sure that the cell well represents the real environment that is experienced by the materials in a real working device. And at the same time, we want to make sure that the actual changes that are happening in your electrochemical cell are reflective of those changes in a real system. The second part of the work package is really about procedural optimization. So a good example of one of the challenges in operando spectroscopy is beam damage. So when you're using a spectroscopic technique, you may actually influence the sample. You may actually change the sample chemically or structurally by probing it in that way. And so what we need to do is optimize our measurement conditions so as to minimize that kind of damage, and again give us more confidence that the data that we're generating is as true as it can be. And then the very final part of the work package is to bring all of that together and actually put it to the test through inter-laboratory comparisons. So we'll be sending out operando cells to various partners, and we'll have optimized our measurement procedure by that point so that a number of different laboratories can basically undertake the same experiment, and then we can get a good idea about how the data varies across different laboratories and maybe understand where the sources of uncertainty might be. And together all of that information will help us produce a good practice guide or a best practice guide that can be disseminated across academia and industry so that everybody can adopt this best practice and hopefully make comparability of data across different laboratories a lot better.